This is Honors Pre-Calculus Review number 3, beginning with question number 21. We have the function f of x equals 3 to the x, and it wants to know if we are reflecting over the x-axis and translated 5 units to the left. Well, to translate or to reflect rather over the x-axis, we put a negative in front of 3 and translated 5 units to the left. Our x would translate 5 units to the left in this fashion. Moving to number 22. This time we are reflecting about the y-axis, and we are stretching vertically by a factor of 7. So my g of x will now be a 7, which is the vertical stretch, times 9. And a reflection over the y-axis would mean that we would make our x negative. So we end up with this equation. Moving on to number 23. We will be solving each equation. My first step then would be to add 7 to both sides, and I would end up with 3e to the 2x equals 57. I would divide both sides by 3. And because my power is a variable, I need to use logarithms to answer this question. So I'm going to write log base e of 19 is equal to 2x. But we know that log base e is actually ln. So to solve for x, I'm going to use the ln of 19 and divide by 2. It says your answer may be exact in terms of logarithms or correct to 3 decimal places, or 3 places after the decimal. If I go 3 places after the decimal in my calculator, I have 1.472. Moving on to the next equation, I have 2.8 to the x equals 345. In this particular case, because the variable is a power, I'm going to use logarithms to answer the question. I'm going to rewrite this as log base 2.8 of 345 is equal to x, and I'm going to use my change of base equation in order to be able to enter this in my calculator. And I find that x is approximately 5.675. Number 25, I'm going to solve. My first step will be to subtract 20 from both sides. I have 5 times 2, 3x minus 1 is equal to 500. I'm going to divide both sides by 5. And then I'm going to use logarithms to solve. This would be log base 2 of 100 would be equal to my power of 3x minus 1. I'm going to use change of base. That would be log of 100 divided by log of 2 is equal to 3x minus 1. This would be equal to 6.644 is equal to 3x minus 1. Adding 1 to both sides is 7.644 is equal to 3x. And dividing by 3 on both sides, I end up with a solution of 2.548. Moving to the next equation. Number 26, I'm going to go to a power since my variable is not as a power yet. So I can rewrite this as log base e of x plus 4 equals 2 and go back to powers to solve. And when I do, x is approximately 3.389. Number 27, again, the same situation. I'm in a log where the variable is here, so I want to go back to powers to solve. So that would be 7 squared is equal to 3x minus 1. So we have 49 equals 3x minus 1. 50 equals 3x, and x is 50 thirds, which is 16.667 approximately. Moving to number 28. In this particular case, I used my properties to condense this into x times x minus 4 equals 1. Now I'm going back to to powers. Setting this equal to 0 and factoring. This factors into x minus 5 times the quantity x plus 1 equals 0. I set each factor equal to 0. I have x equals -1 and x equals 5, but I know that by definition I cannot have a negative in this position right here. This is an extraneous solution. And my answer is x equals 5. Moving on to number 29. Pardon me. Going to put this back together again. This is log base 2 of x plus 5 over x minus 1 equals log base 2 of 2 squared. This is log base 2 of x plus 5 over x minus 1 equals log base 2 of 4. I know that when they're both to the same log and base, that I can examine this piece. I'm going to continue this problem by 4 times the quantity x minus 1, if I cross multiply, is equal to x plus 5. I have 4x minus 4 equals x plus 5. This gives me 3x equals 9 and x equals 3. There were a couple ways I could have solved this piece of it, but I recognize that if they are both the same here and there's an equal sign between them, these may be set equal to each other to continue. Moving to number 30. Number 30, I'm going to put my two log expressions on the same side by addition. I have log 20 plus log of x. I know that the property allows me to put this back together by multiplication. Since I have my variable here, it would be best to go back to powers, and I know that when I have a common log, the base is 10. So I can say that this is 10 to the second power equals 20x, or 100 equals 20x, or x equals 5. All right, the video will stop here, and we'll pick up on the next video.